So for this video, what we're going to talk about is specifically a special type of function that has multiple rules to it. Now, we talked about earlier how a specific function has a rule to it where you plug something in, you get a specific number back. Okay? And what we're going to talk about now is this idea of what's called a piecewise function. And if you break this down, what it means is that there are specific pieces that this function has to it. And what it is just represents multiple functions for certain x values. So how you could interpret this is just that it is a function that behaves certain ways for certain x values and different ways for different x values. Okay? So for certain pieces of the function, it follows one rule, and for certain other pieces it follows a different rule. And it might be more than 2 rules, it might be 10 rules, but all you need to know is that it might break apart into different rules for different x values. Okay? That's why there's this word piece in there for specific pieces. Okay? So the way this looks is if you're going to graph a function that has specific pieces, okay, what this looks like. We have this function, and this notation just means, okay, here's one rule, and here is the second rule. Now if I were to graph this separately, if I were to graph each one of these separately, there's 2 ways you can graph this. This is the first way. If I were to graph this separately, and if it was just this first rule here, what I would do is I'd graph this. I could use a table, I could use any way that I want to, but I know that this is the same thing as negative 1x, so I would start at 0, I'd go down 1 over 1 with a slope. It would look something like this. So that's this graph. Now, if I were going to graph the second one, I would graph it like this. So I'm going to the second graph, and again, this is just a line y equals 1. So I would go up 1, and it would look like this. So this would be if these two things were completely different. This is one versus the other. Now we're going to combine them. And you might say, well, how am I going to combine these? Wouldn't it just look like this? And wouldn't this fail the vertical line test? Well, yes it would. But this right here is the key to telling us how to graph it. This tells us which x values to use. And this right here tells us which x values to use. So I'm going to graph this, and I'm going to combine these two things. So I'm going to graph the first one again. But then I'm going to stop and I'm going to rewind for a second, because I am looking for where x is less than 0. So this is my domain. So if this was a domain for all numbers, I would graph this. However, since it's everything less than 0, this is my x-axis here. I don't want every x value. I want specifically all the values less than 0. So here's 0. I want to use every value less than that. So I would go and use all of these values on the graph. So I could use negative 1, negative 4, negative 10. I could keep using values. So this is the part of the line that I actually want. So I want to get rid of the rest of it. So what I actually want to keep for this is all of this. That's all I want. That's the only piece that I want. So really what I want to keep is just that. So I got to get rid of everything else, and then beyond that I got to get rid of the rest. This stuff here I don't want anymore. So now I got to graph the rest of it. If I were to graph the other line, it look like this, but I want x to be greater than or equal to 0. So I want this point right here, and I want everything above it. So for this one, all I want is this. So you might say, well, that still doesn't give me a really nice picture. What does my final product actually look like? Well, I'll tell you what it looks like right here. Take that out of there. I'm going to take this out of there. So the highlighted stuff is what I actually wanted to keep. So what I actually end up with is something like this. I have a line that goes down to here. I'm not using 0 on this one, so I'm going to have an open circle. And then for this line, I'm using 1, so I'm going to have a closed circle. I'm using one piece. This is the negative x piece. I'm using the 1 for this piece. There are my two pieces put together. So this is the first piece, this is the second piece. There are two pieces of graphs just cut together and kind of spliced together in one graph. Now, we've talked about absolute value graphs before, and the reason that it's a natural fit right here is because the absolute value of a number has a piecewise definition. If you take the absolute value of -3, you get 3. If you take the absolute value of +3, you get 3. The absolute value function has a piecewise definition. And it looks like this. I'm going to graph this function if it's negative. I'm going to graph a regular line if it's positive. Now, because these 2 points seem to meet, I can put a dot there. They didn't meet before in the previous one. But this V-shaped graph has a piecewise definition. So if it's negative, I use this rule. If it's positive or 0, I use this rule. So a piecewise function just means to use a rule to define it for different x values. Now, for those of you that have had college algebra, we've talked about composite functions before. A composite function is when you take a function and substitute it for a value. When we plug in a number, that means you plug in this in for x. Okay? You can even take in and plug in a different variable for x. Now we're going to take and we're going to plug in another function for x. Okay? And these are going to be the two notations that you're going to see. This just means f composed with g of x. So you'll see these two things being interchanged. Okay? So all you're doing when you evaluate a function, you're replacing it with a variable. Now we're going to replace it with a function. Okay? So when you see this, we're replacing it with a function. So instead you would see f of 2 or f of 10. Now wherever we see x here, we need to replace that with g of x. So So I'm going to replace that with g of x. So what that looks like is x minus 7 squared. So instead of x squared, it's this whole thing squared. So if I square that out, it's not x squared plus 49. It's x minus 7 times x minus 7. And if I multiply that out, I get x squared minus 7x minus 7x plus 49, which is x squared minus 14x plus 49. So my answer for this is right here for this function. Now if I do this the other way, if I have g of x, which is x minus 7, and I'm asked to replace x with f of x, I'm going to replace x here with x squared. So that's going to be just x squared minus 7, and that's all the further you can go. This can't be factored. You can't go any further than that. Now, this comes the evaluating part where you actually plug a number in. We already defined this function in letter A. We already defined it over here. So now we've got to plug 2 in for the whole thing. So let's see what 2 gives us. So 2 squared minus 14 times 2 plus 49. So 4 minus 28 plus 49, that's going to be 25. If I plug in 2 for this second function, which we have defined, it's going to be 4 minus 7, which is negative 3. And you could do this a different way. You could plug in 2 to this equation, and you would get 2 squared, which is 4. So that whole thing is 4. So instead, then you would plug in g of 4, because that is now 4. And if you plug in 4 to that, you get 4 minus 7, which is still negative 3. Two different ways you can look at evaluating this type of equation. Now, for the next section, we are going to talk about it in a different order. It is 1.4, but we are going to talk about how things grow not linearly and in a linear way anymore, but exponentially. And these two problems that you see that are left blank, we will talk about in class. So in the next section, after we talk about functions, we're going to talk about how things grow exponentially versus linearly, or in a linear way. But this section was about how to deal with functions.